reduced SWaP zoom lens designed for MWIR 10 micron VGA FPA. The outline of my presentation is shown here. First, I will give a short introduction to infrared thermal imaging trends and application drivers, and talk about the challenges for the optics. Then I will describe the continuous zoom folded optic design and the challenges we have in designing such systems. Then we will go to introduction of our new product, which is the LiteIR 16-180mm f3.6 folded optic zoom lens. We will see its key features and performance, and we'll conclude with a short summary. So let's start with the introduction of infrared thermal imaging trends and application drivers. So one of the most interesting trends today is growing use of small UAVs and drones for various applications, such as security and surveillance, homeland security, border control, etc. These applications require reduced size, weight, and power, which is called SWaP, and also increased operational ranges. Another trend is growing use of handheld lightweight thermal imaging systems for various applications. Also, there is growing demand for long-range, all-weather security and surveillance systems. On the detector side, there is a need for increased camera resolution and format, which means that sensors have gone to high-definition formats and the pixels are shrinking in size. The new generation of focal plane arrays and detectors have pixel size of 10 micron. In short, there is a need for high-performance, low-SWaP optics suitable for small pixels, long-range detection, constrained platforms, and harsh environmental conditions. And this is actually the reason for the challenges we have in designing and manufacturing the new generation of infrared optics. So the challenges are advanced detector resolution will not improve imaging performance without an improvement in lens quality. This means that if the system is optics limited, an inferior lens will produce an inferior image even with the best detector. So in order to utilize the advantages of the new detectors, the optics should be at the highest level. Otherwise, the performance of the whole system will be degraded. In order to match high-performance detectors requirements, the optics should have low F number, tight tolerances, and minimum aberrations. Also, the lens assemblies must have low SWaP, long focal lengths for increased operational ranges, high image quality, and they should be operational at harsh environment conditions. So how do we address these challenges? First of all, by using continuous zoom lens designs. When using zoom lenses, we can keep the high performance with reduced size and weight of the lens. Zoom lenses are smaller and lighter compared to multiple single field of view lenses. And also, better mission flexibility can be achieved by allowing changes in magnification during operations. This means that by clicking a button, the field of view can change from the narrow to wide or zoom in and zoom out continuously. Also, innovative optical design are required in order to meet these challenges. And we use advanced infrared materials with aspheric diffractive surfaces in order to reduce the number of elements while keeping the image quality very high. In this way, we can design diffraction limited systems. Also, athermal designs. Athermal means that the image is kept sharp in focus even when the temperature changes. And as you know, optical materials in the infrared region are very sensitive to temperature changes. Another technique we use is folded optic configuration, which saves both size and weight. We also design systems with fixed F number throughout the full zoom range. On the mechanical side, we use advanced materials which can give us athermal designs and also small size and low weight. The focus is maintained through the whole zoom range. We can achieve also fast zoom and focus movements, very tight borsat errors, low power consumption, also wide operational temperature range can be achieved with our designs, and our lenses are operational even at harsh environmental conditions. We also use our cutting-edge production technologies in order to build the high-quality lenses by utilizing our capabilities in manufacturing all types of surfaces, of optical surfaces, like spherical, aspheric, diffractive, and even freeform surfaces. We can also achieve very tight manufacturing tolerances, which improve the image quality of the final product. We have also capabilities to manufacture large diameter optics, which is required for long focal lengths and long operational ranges. The external coatings in our lenses are very durable and we use high durability coating and also low reflection hard carbon coating, which we developed. We will now move on to the folded optic continuous zoom lens designs. The motivation for designing folded optic zoom lens is first, shorten the system overall length while maintaining long focal lengths. Second, the long optical length reduces the sensitivity to tolerances, so we can achieve better performance of the lens and better image quality. Also, by folded optic, we can achieve very efficient utilization of the volume and compact design. As you can see here on the sketch, the detector assembly with its cooler are included the same package of the lens. So the overall system size is very compact and very small. This is why this configuration is ideal for airborne gimbals and for constrained platforms. However, folded optic design has many challenges. First of all, complicated optical design because of the folding mirrors and because of the long lengths of the optical path. The optical design is more complicated. Secondly, the integration and calibration of such a lens is much more complex than standard designs. Another challenge is extra optical elements within limited volume and weight, which means high density of components. And there is also the issue of image tilt, which we should face and correct for it. I would like now to introduce our new product, the LiteIR 16-180mm f3.6 folded optic continuous zoom lens. The key features of this product is it is a folded design, zoom lens. The spectral range is 3.6 to 4.2 micron. The FPA format is VGA 10 micron pixel pitch. Zoom ratio is 11. Operating temperature range is between -32 up to +75 degrees centigrade. And it has a small footprint, which is SWaP compatible. You can see on the right side images of this product. Here you can see also the detector and cooler assembly mounted on the lens. We will now describe the performance of this product. In this graph, you can see the MTF performance at the wide field of view, which is 16mm focal length. The upper graph is the diffraction limit, and you can see that the quality is close to the diffraction limit throughout the full range of the field, from center up to the diagonal edge. Here you can see the distortion and field curvature of the wide field of view. As you can see, the distortion is less than 2.5%. In the following graphs, we will see the performance at the other focal lengths. This is the MTF at 30 millimeter focal lengths, again, close to diffraction limit. And this is the distortion for the 30 millimeter focal lengths. This is the MTF at 70 millimeter, and this is the distortion. This is the MTF at 100 millimeter focal lengths, and distortion, 150 millimeter focal lengths. Again, you see the MTF is close to the diffraction limit. This is the distortion at 150. This is the MTF at the narrow field of view, which is 180 millimeter focal lengths. You see that the optical performance is close to the diffraction limit in the entire image frame and zoom range. And this is the distortion at 180 millimeter. This is the image of the lens with the detector and its cooler. This is another image from the backside. Again, the detector is also included here. We will now see a short video presenting the images we can achieve with this lens, real images that were taken with the lens. So this is the lens, 60 to 180 millimeter folded optic zoom lens. Lightweight, small size, low power consumption, ideal for small gimbals. This is the image. You see here, the target is at 2.9 kilometer distance. This is zooming out. Zoom in, 2.9 kilometers. This is 4.4 kilometers target. Zoom out. Zoom in. This is 6.1 kilometer target. Zoom in, you can see the details even at 6 kilometer. Zoom out. Okay. Summary. So advanced low SWaP infrared zoom lenses are based on innovative, lightweight, and folded optomechanical concepts suitable for small pixel FPAs and long-range detection. Our new product, the LiteIR 16 180mm f3.6 continuous zoom lens, meets low SWaP demand with long EFL capabilities. It has an efficient folded optics design for maximum volume use. It is designed for medium wave 10 micron pitch VGA sensors. It has excellent image quality. It has wide zoom range. It is operational under harsh environmental conditions, and it is ideal for small gimbals thermal imaging applications. And with this, I would like to conclude. Thank you very much.